So for the first one here, this is a block with a hole drilled through it, or cut through it, whichever way you want to look at it. So to find the volume, we're going to find the volume of the block first, of the box. And of course, the first step is to find the area of the base. If I let the base be just this box on bottom, how do I find that area? That square on bottom. "10 inches by 10 inches, there we go. Or 100 square inches. So then the volume is found by doing what? Take the area of the base times the height of 12, good. So we've got a volume there of 1,200 cubic inches. Now we have to find the volume of that hole, and any circular hole is going to be a cylinder. So for that hole, the base is just that circle. How do I find the area of that base? Pi times 3 squared, pi times radius squared. What's that give us? 28.26 square inches. And then to find the volume, $339.12 cubic inches. So we just multiply that area of the base to 28.26 is the area of that circle times that height to 12 inches again. You get 339.12 cubic inches. And now we're going to subtract. The whole box of 1,200 minus the whole of 339 gives us perfect, 860.88 cubic inches of volume. Not so bad. Just combining a couple of things. The hard part is seeing it and being able to put it together. Surface area, excuse me, is going to be a little bit more difficult. So we're going to start with the box again. And of course, we have the area of the bases, so we're going to focus on the lateral area first. What are the two things we need to know for lateral area? The perimeter around the base and the height. So we need the perimeter of the base here, which is just 40. Good. 10 inches times 4, or 10 plus 10 plus 10. We got 40 inches is the perimeter of the base. So lateral area will be that perimeter of the base, 40 inches times the height of 12, which gives us 480 square inches. Now to that, we need to add the area of the bases, which is 100 each, right? So we got 680 square inches of surface area for the box. Of course, there's holes cut out. Those holes cut out, of course, are just the circles or the area of the base for the cylinder. So we have to subtract the 28.6 twice. Yep, 28.26, sorry. What's that give us? .48 square inches, okay? Now we have to add in part. There's a surface that's been added here, and that is the sleeve, basically, of the hole. So that's the lateral area of the cylinder. So to find the lateral area of the cylinder, what two things do we need to know? Height and perimeter of the base. Good. The perimeter of the base here is just going to be a circumference because it's a circle. Pi times 6. There we go. Which gives us 18.84 inches as our circumference. So that lateral area is 18.84 inches. Distance around times the height of 12 inches, which is 226.08 square inches. We have to add that to what we had from the box. $849.56. That's a little tricky. Like I said, volume is easier because it's strictly additive. You either add it or subtract it. You don't have to worry about surfaces that are covered up. Surface area is a little trickier because some surfaces are covered up, so you don't have to count them. Like here, the lateral area, or the area of the base of the cylinder is actually cut out, so you actually have to subtract that rather than adding it in. So the surface area is a little bit trickier. Number 2 over here helps if we redraw it as an 8-inch square. What's the area of that square going to be? 64. Good. Just 8 times 8. And then cut out from that is a quarter circle. How do I find the area of the quarter circle? Well, the radius is 8, so pi times 8 squared, and then it would be times 90 over 360, or we could just divide by 4. Either way will work. So what does that give us? That sounds right. 50.24 it is. So then we have to subtract to get the area of our base here, which is this shape here, which is what, 13.76? So that's the area of our base. So that's this area right here. So for volume, yeah, we're just going to multiply by 14, exactly. $192 point what? 64 inches cubed. So once you can find the area of that base, it's not that bad to do the volume. This is one where the surface area is not that bad either. We have to find the lateral area, which requires us to find the perimeter of the base. Well, we have our base looks something like that. This is 8 inches. This is 8 inches. So our perimeter here is 8 inches plus 8 inches plus, how would we find this? Well, circumference of the whole circle would be pi times, not 8, but careful, 16. The radius here is 8, circumference is pi times diameter. And then, of course, it's 1/4 of a circle, so we divide by 4. Get 12.56. So that adds up to a perimeter of the base of 28.56 inches. What do we do with that? Not added to, but multiply by so what we found was the distance around the base here. So we're going to multiply by, you're reaching on me. Now remember, if we take this and we unfold it, we're taking the lateral surfaces, this rectangle, and then this curve, and we're unfolding it into one big rectangle. The length of the rectangle is the perimeter of our base here that we just found. The height of the rectangle is 14. There we go. So it's times the 14-inch height. This is just perimeter of the base times height for lateral area. So 28.56 times 14. 399.84 square inches. Now that's just the lateral area. What do we have to add to that? Yeah, the 13.76 twice, both ends. So 427.36 square inches is the surface area. I realize there's a lot of steps and a lot of formulas. Hopefully you're starting to see some patterns from one shape to another where, like I said, that surface area, you usually have the area of the base already from finding the volume. And so it's just the perimeter of the base, the distance around the base times that height for lateral area, and add in the bases. Some days I wish I could draw. Now we have done, that's not really what I wanted to do there, but we'll work with it. We've done boxes, we have done shapes like this, but let's do this as, let's just do 8 inches by 8 inches by 8 inches by 10 inches. So this is an equilateral triangle that we've used to create this solid. For volume, we start off with the area of the base. How do we find the area of the base for this? This is where we have to do Hero's formula, yes. If we don't have two dimensions that are perpendicular, if we don't have any two dimensions that form a right angle, we have to use Hero's formula. We can find the area of a triangle just from the three sides. So Hero's formula, the perimeter of the triangle is what? There we go, 8 times 3, 8 plus 8 plus 8 is 24 inches. What do we do from there? Divide by 2. Semi-perimeter is half of the perimeter. And then, of course, the formula for the area is the square root of the semi-perimeter times the semi-perimeter minus side A times the semi-perimeter minus side B times the semi-perimeter minus side C. So here the semi-perimeter is 12, 12 minus 8, 12 minus 8, and 12 minus 8 because all the sides are the same. $27.71, yep. That'll be square inches is the area of our base. So the volume is the area of the base times Found the area of our base times the height of 10. So 277.1 inches squared. Excuse me. Surface area here, we've done most of the work already. For the lateral area, we've already found the perimeter of the base. It was 24. So that's the distance around the bottom. What do we multiply that by? The height of 10. Good. So that's 240 square inches. To that, we're going to add the area of our base twice. $295.42. Is our surface area. Now, the reason I did that example is so I could do this one. A pyramid on that equilateral triangle. So this is still 8, 8, and 8. The height of this pyramid will be 10 inches. So it's the same figure. It just comes to a point instead of having a base at the top. So the area of my base is still just the 27.71. Come on, hold still. How do I find the volume from that? So times the height of 10, and then divide by 3, because it's three-dimensional. There we go. So what's that give us? $3.7? Okay, 92.37 cubic inches of volume. I'm not going to force you to do the surface area here because the surface area is a real pain. Remember, to do surface area, we had to have slant height. Well, the problem is the center, the peak of this is going to be over right at that point right there. That point, if I draw in an altitude here so that it comes from one vertex to the center of the other side, if I draw all of those in, they should intersect at a common point. That's the point that the peak is over the top of. But I'll show you the start of it just to, so you can appreciate what a pain it is. But I would never, ever make you do this. I don't hate you guys that much. Yeah, you're just saying give it time. We still have 19 more weeks left. Actually, you guys have like 21 more weeks left because I start 2 weeks early with you guys in January. It gets me out of some meetings the first week before the semester starts. So we're over that point. Well, that point, I draw it in a little bit better here. That point, if I draw in this line, is actually 1/3 of the way up that altitude. But I don't know the length of that altitude. But I could. If I cut this triangle in half here and just take that, this is going to be 4 inches, half of the 8. This will be 8 inches. I can find that length by labeling it side A. That would be side A. Which one would be side B? 4, and of course the hypotenuse, side C, would be the 8. A and B have to be the legs. They have to form the right angle. So A squared plus B squared equals C squared. We know, well, we're looking for A squared, but we know B is 4, so that's 4 squared, and C is 8, so that's 8 squared. So we're not going to do anything with the A squared yet. What's 4 squared? 16. What's 8 squared? 64. So now we will subtract 16 from both sides. A squared equals 48. And then how do we find A? Square root. So A equals 6.9 what? 6.93 inches. So this whole length here is 6.93 inches, which means 1/3 of that is 2.31. Does that make sense? So why do we need to know that? Well, because if we go back to this pyramid thing, actually I need to draw it a little better than that. We'll draw it this way. I need to know the slant height to get my surface area, my lateral area. Well, that slant height is going to be based on a triangle, that red triangle I draw it out here. This distance down here is the 2.31 inches. And of course, we have the height of 10 inches. We would use that to find the slant. Find the slant for me quick. $10.26 inches. So now our lateral area, we have the perimeter of the base was 24 inches. That was just the 8 plus 8 plus 8 times that slant of 10.26 inches. Because this is a pyramid, that means those lateral surfaces are triangles. So what do we have to do? Divide by 2. This is going to be area, so you divide by 2. So what's that give us? What? 123.12 square inches for lateral area. And of course, to that, we just have to add our base of 27.71 once. Giving us 150.83 square inches is our surface area. So I ended up doing the whole thing, even though I said I wouldn't, but those aren't fun. That's why the ones I give you have a square base, because it's easy to locate where the peak is over the center, whereas with the triangular base, it's a pain. Okay, so I am done pounding areas, volumes, and surface areas into you. How many of you feel comfortable doing it? Maybe. The surface areas are a little trickier. So what we're going to do is we're going to work on a couple of other things for a couple of hours of class. Give you a break from these, because I think we've spent about 6 hours on them in a row now, and I think I've overloaded you a little bit. So we're going to back off, do some other things that I think are a little simpler, or at least a change of pace. One of them is an application of this stuff. If we were trying to find concrete for a house foundation, there are 3 pieces to a foundation for concrete. One is the footings, second is the wall, and third is the floor. So if we have a foundation, let's say that this is going to be 32 by 44 feet. And we're going to do a poured wall, so let's say that we are doing 8-inch thick wall by 9 feet high. It's common to do like an 8-inch, 8 foot 3-inch, 8 foot 6-inch, depending on what you're doing. If you're doing like a top cord supported floor truss, you guys have any idea what that is? When it comes to floor trusses, there are two types. So here's your concrete wall. You have some sort of a treated sill sitting on top of it. A bottom cord supported. Is pretty much just a rectangle. It'll look something like this. Sits on top of the wall. The bottom cord, the bottom of the truss sits on top of the wall. By the way, this little notch here is so you can put a 2x4 or a 2x6 straight down the wall to hold them all together to keep them straight. Top cord supported. Looks like this. There's a couple of blocks here. And it looks like that. So the advantage to the top cord supported is your floor is only going to be 8 or 9 inches above the top of your concrete wall. The disadvantage of them is your ceiling is going to be, I mean, if these are 18 or 20 inches thick, your ceiling might be 12, 14 inches below the top of your wall, your basic ceiling. So now you have to have a 9-foot high concrete wall to make up for the fact that that truss comes down into the concrete. Don't ask me which one's better. As far as ease of setting, they're about the same. This one's nice. You can butt that up against the wall so you don't push it over too far, but if you're trying to work them in and out, then that can be getting in the way a little bit too. These are what? What's that? Yeah. Yeah. These can slide off until you get them fastened down. These are kind of wedged in there. These are a lot cheaper, I will say that. I really have never figured out what the huge fascination is. These are very common in certain areas. I've never figured out what the fascination is. I prefer the bottom cord bearing just because they're cheaper and you don't have to account for the extra wall height. Anyway, we're going 9-foot high wall, 8 inches thick. So what that means then, that's for the wall. So what that means for the footing is that our footing has to be at least 9 inches thick. And 16 inches wide. Our floor is just going to be a standard 3 inches thick. So let's start out with the footing. Our footing has to go, well, let's do this. We'll draw on our wall here quick. Now, if this is 8 inches, and this is 8 inches, get out of there. we've lost a total of 16 inches off of that dimension to get to the inside, right? This dimension here from the 32 feet. 16 inches. We're going to put it over 12 inches to make that 16 over 12. Both divide by 4 gives me 4/3 or 1 1/3 feet. Everybody see where that comes from? Does that make sense? Okay. So we've got 1 1/3 foot there, which means 32 minus 1 1/3 means this dimension in here is 30 2/3 feet. What's this dimension here going to be? $42 2/3, yeah. So now the footing has to be twice as wide as the wall. 8-inch thick wall, 16-inch wide footing. So that means the footing has to go 4 inches or 1/3 of a foot on either side of the wall. So let's draw in this here. Obviously, I exaggerated the size a little bit. So I'm going to add 1/3 of a foot here and 1/3 of a foot here, which of course is 2/3 of a foot. Make sense? So this dimension here is going to be 44 plus 2/3. It's 44 2/3 feet. Make sense? What's this one here going to be? 32 2/3. On the inside, if I subtract 2/3 of a foot, well, 42 2/3 minus 2/3 is just 42. 30 2/3 minus 2/3 is just 30. Come on. So I got 30 feet there. So my footing, I find the area of the base for my footing. I have 2 rectangles. I have a big rectangle, 44 2/3 by 32 2/3. Now to put that in the calculator, just be parentheses 44 plus 2 divided by 3, close parentheses, no 9 there, get out of there. Times, parentheses, 32 plus 2 divided by 3. We get 1459.111 square feet. How big's my inside part? It's just 30 by 42, right? There we go. That's 1,260 square feet. If I subtract, I get about 199. Let's just call it 200 square feet. 199.111. We'll call it 200 square feet is the area of that footing. The volume then is that area of 200 square feet. Now our thickness is 9 inches because we're 9-foot wall. You have to have 1 inch of thickness on the footing for every foot of height on the wall. 9 inches of thickness is 9/12 of a foot. So what does that give us? $150? So we had 150 cubic feet. We order concrete in cubic yards. How do we convert cubic feet to cubic yards? 27, there you go. So we divide by 27, we get 5.27 5.6 cubic yards. Probably around, usually you round up to the nearest quarter yards, you probably go 5.75, 5.75 yards. So 5.75 cubic yards of concrete for the footing. Now that's a little bit of work, but it could be worse. Let's look at the wall. So for the wall, we have big rectangle of 44 by 32. Here, let me just draw this out quick. 44 by 32, 30 2/3 by 42 2/3. So on the outside, we have 1480. So 1,480 square feet. On the inside, $1,308.44, yep. Now I'm just going to subtract 1,308. So does that give us 172? Yeah, 172 square feet, we're going to call it. Technically, it's 171.55555. We're going to call it 172 square feet. So the height of our wall was 9 feet. So our volume, there we go, 172 square feet times 9. Come on, screw it. What'd you say, 1,548 cubic feet? And of course, we're going to convert that into yards. $57.3. So we'll go 57.5 is what we would order. For the wall. Now the floor is actually really easy to do because the dimensions of the floor are the inside of the wall. We already have that area. Area of the inside of the wall is the 1,308.44. So the area is 1,308. We're going to round it up to 0.45 square feet. We said the thickness was 3 inches, so 3/12 of a foot, which gives us perfect, 327.11 cubic feet. Of course, we have to find cubic yards. What's that? 12.25? Okay. 12.11? Okay. So you are absolutely correct. 12.25 yards is what we would order there. So that idea of the area of a base times a height makes this process relatively simple. I mean, you got to work with some ugly fractions. And it's even worse if you have a 10-inch thick wall because it's not a nice 1/3, 2/3 anymore. But you guys get the picture. Let's take our break. We'll start up at 2:30 again. Back at her. So a little bit of a change of pace here. We're going to talk about the difference between volume and capacity. Well, volume we've been working on for the last few weeks. Volume is from length measurements. And it's the units are length units cubed. Inches cubed, feet cubed, centimeters cubed, meters cubed, whatever. Whatever length unit we use, it's that unit cubed. Well, capacity is from standard size containers. Capacity and volume really are measuring the same thing, just in two different ways. Unfortunately, there isn't convenient conversions between the two. Let's start out with one of our main units of capacity, the gallon. Anybody know where the gallon comes from? A gallon actually originated as the amount that you could hold in a men's hat. Now, obviously not a baseball cap or a cowboy hat. It was the European style dress hat, like the derby style hat. That gallon was actually smaller than what we have as a gallon right now. We've adjusted it to make it fit with other units, so it was a little bit smaller, but that's where the gallon came from. The cowboy hat, they say, 10-gallon hat. Obviously that doesn't hold 10 gallons. It was just kind of a sarcastic comment of, oh, look at that big hat. Look at that 10-gallon hat there. Smaller than a gallon, what do we have? A quart. Well, pint is smaller too, but quart comes first. How many quarts are in a gallon? 4. Yeah, a quart actually comes from the term quarter gallon. So there's 4 quarts in a gallon, or 1/4 of a gallon. Smaller than a quart. Well, Ryan had it. The pint. How many pints are in a quart? 2. 8 pints in a gallon, 2 pints in a quart. Now, the quart obviously came from the gallon, a quarter gallon. A pint was a standard size container. It was a jar, could be used for serving beverages, a quart of ale, quart of whiskey, quart of beer, pint of beer, pint of whiskey, whatever. Or for preserving vegetables. They had the pint jars, or standard size jars. The size of the pint stayed relatively the same, made it a little bit larger to fit with the next smaller unit. But when they had to adjust the quart, make the quart bigger so that 2 pints would fit in it. So when they made the quart bigger, that's when the gallon had to get larger as well to still keep 4 quarts. So that's why the gallon, like I said, is quite a bit bigger now. The standardized gallon is bigger than what the traditional gallon was. Now, if you have any dyslexic tendencies like I do, your abbreviation for a quart is QT, for a pint is PT. Be very careful with those. I carelessly screw those up all the time. Smaller than a pint, we have an ounce is smaller, but there's one in between there. Cup. How many cups are in a pint? 2. The pint was wet measure. The gallon and the quart could be both wet or dry measure. A cup was dry measurement. It was for like flour, salt, sugar. There's a cooking unit. If you take your cupped hand and fill it with flour, what you heap up in there, that is a cup. So that they kept the same, and they adjusted everything else to kind of fit with that, going up or down. I have a couple of friends who are caterers and bakers, and that's how they measure it. I've checked them, and they're like dead on every time. Smaller than a cup. There's the ounce. Anybody know how many fluid ounces are in a cup? 16 in a pint, 8 in a cup. That's why a pint is sometimes referred to as a fluid pound. Smaller than a fluid ounce, we have tablespoon, then teaspoon, yes. 2 tablespoons. Yeah. Tablespoon is your bigger spoon for eating. A teaspoon is your small spoon for putting sugar into your tea. They actually were There's 2 tablespoons in a fluid ounce, by the way. The tablespoon, the European style spoon, was quite a bit larger. It was for eating liquids like soup and whatever. So it's a little bit larger than what we typically use for our spoon right now. And yes, the tablespoon contains 3 teaspoons. The teaspoon was like a tiny little spoon that was used for adding sugar to your tea. 1 teaspoon was equivalent to 1 sugar cube, so it was a little bit smaller. Little note there, your abbreviations for tablespoon, you could have capital TSP, capital TBSP is the one I used, or just capital T, or you could have a small TBSP. The reason I give you the warning is because for teaspoon, you can either have a small TSP or just a small t. Notice both of them have TSP. It's a difference is a capital T and a small t. So you've got to watch very carefully. If your recipe for chocolate chip cookies says 2 teaspoons of salt and you screw up and put in 2 tablespoons of salt, I have not thrown away a lot of cookie dough in my life, but there was no amount of milk making those cookies go down. Now, smaller than each of these, what's that? Yeah, I had actually baked the cookies and they were salty as heck. If it was still cookie dough, I probably could have saved them by just making more cookie dough and mixing it together, but no, Put them back into the cookie dough. I tried soaking them in milk. I haven't thrown away a lot of food in my life, obviously. Yeah, it just wasn't going to happen. Now, these next ones you don't need to write down if you're writing them down. Smaller than a teaspoon. 1 teaspoon contains 6 dashes. Now, a dash, now you've probably heard you always just put a dash of this in. Well, no, you're thinking of one coming up. Like a salt shaker or pepper shaker, a dash is just one big shake, that's a dash. Well, they had spice shakers that were bigger, but they still function the same way as a salt shaker. A dash was just taking it, and 1 dash of the shaker was a dash. 1 dash contains 2 pinches. A pinch, you just put your fingers into the salt, pepper, spice, whatever spice, put your fingers together, what's between your fingers goes in the recipe. That's it? Yeah. For the most part, it worked okay. They actually do make measuring spoons for dashes and pinches. And for this last one, 1 pinch contains 2 smidgens. That's a natural thing, a smidgen. This one kind of grosses me out a little bit. You stick your finger into the spice and whatever sticks to your finger goes in the recipe. Of course, I'm always picturing the cook going, of course, it cooks it off, right? I hope. It still grosses me out a little bit. What's that? It looks a little bit overcast out there. Okay, bigger than a gallon. Has anybody ever heard of a peck? The old rhyme or what tongue twister, Peter Piper picked a peck of pickled peppers. If you ever go buy strawberries, you have the trays, there's 1 peck and 2 peck trays. Or if you go to an orchard to buy apples, usually it's 1 peck or half peck bags. 1 peck is 2 gallons. One bushel is 4 pecks or 8 gallons. Fitting in with the earlier conversation, you know how big a barrel is? Close. I heard the 55 come up there. 55 gallons is a drum. A barrel is 31.5 gallons. So a half barrel is 15 3/4. Quarter barrel is, what, 7 7/8. There's bigger ones like a hogshead and stuff like that we're not going to get into. Now, like our other units, our units of capacity were developed completely independent of our units of weight, or of volume. So there was never an intended or designed conversion between them. At some point, they just had to sit down with a gallon and made a scoop or whatever that was 1 cubic inch and scooped them in and counted to see how many it took to fill. So we come up with an equivalency that 1 gallon is approximately 231 cubic inches. And 1 cubic foot, now you guys are familiar with a 5-gallon bucket, right? Would you say that's more or less or about equal to a cubic foot? About equal? Most people would say about equal. It's actually considerably less. 1 cubic foot's about 7.5 gallons. So a 5-gallon bucket's only about 2/3 of a cubic foot. Now you think about it, it's taller than a foot, but on the bottom it's only about 9 inches and it's round. So those lost corners make it quite a bit smaller than a cubic foot. But most people are surprised by that. Most people would say 5-gallon bucket is really close to a cubic foot. So because of those conversions, if we look at like a standard size gas tank, so let's look at something about like this and see how many gallons that would hold. So for our base, we're going to use the 40 by 16. So 640 square inches. So our volume would then be the 640 times the 6 inches, which is 3,840 cubic inches. Now to turn that into gallons, there you go. 231 cubic inches is 1 gallon. So 16.62 gallons, which is pretty close to your normal gas tank size on your vehicle. What's that? Yeah, I've got a friend who drives an old Suburban that I think he has a 28 and a 24-gallon tank or something like that in it. And when gas was at like $4 a gallon, I think he said it took him like $200 to fill the tank to fill the tanks. Yeah. 32? Yeah, that's enough to fill. That's what do you get, about 13 or 14 miles a gallon? 15? Now we did a problem similar to this, where we had a tank with the half sphere on each end. Let's do this. We're gonna go 3 feet there and 6 feet here. So our radius is 1.5 feet or 1.5 feet. So our volume, we have the cylinder, which we'll do first, with a radius of 1.5 feet and 6 feet. So what do we do here? How do we find the area of the base? Perfect. Pi times 1.5 squared. Wait, 7.065? So by that, 7.065 square feet. So then our volume times the 6 feet of height, yes. 42.39 cubic feet. For the sphere, that is just one complete sphere with a radius of 1.5 feet. How do I find the volume of that? This is that ugly formula that we gave you a couple days ago. 4/3 times pi times radius cubed. So to put that in the calculator, it's just 4 divided by 3 times 3.14 times 1.5 cubed. 14.13 cubic feet. So that adds up to 56.52 cubic feet. How do I turn that into gallons? $7.5, good. 1 cubic foot is 7.5 gallons. Which gives us 423 point what? 9 gallons. What's that? Well, I mean, that's a little bit smaller than a standard LP tank. An LP tank would be 500 gallons. I believe a standard LP tank is 3.5 feet in diameter instead of 3 feet in diameter. And then it's like 6.5 or something like that long on the straight side. They'd probably consider it a 4.25, 425. You know, that's got to be up there. Because what is that, like a 6-foot radius or 6-foot diameter and like 28 foot long, 30 foot long? Well, we've got a moment. Let's do it. So 6 foot, actually, probably closer to an 8 foot, yeah. Because I think you're allowed to go up to 9 foot before you have to have a wide load. So probably more like 8 foot and then like 30 feet long. So our area of our base would be pi times 4 squared, or 50.24. And then our volume, 1507.2. Perfect. So 1507.2 cubic feet. To turn that into gallons, times 7.5 gives us 11,304 gallons. You know, I guess now that we get to that number, I've heard 10,000 gallons thrown out a lot, so that's probably about what they hold. I know. What's that? 1 gallon's about 8 pounds. So yeah, they're carrying probably 80,000 pounds. I know for a farmer, if you get antibiotics in your milk, that's a big deal. You're supposed to call it in. They're supposed to come out and test your tank, and if it's bad, they drain it. Otherwise, if you don't call it in, when they pick up your milk, they take a sample out of your tank and they take that back and they test those samples. If your sample tests so that it's too high in the antibiotics, then they test the whole truck. And if that truck tests where it's too high, you pay for that whole truck. So you think about it, the average farmer is sending like 1,000 gallons, if that. 500 to 1,000 gallon tank is standard for the family farms. The bigger farms send a semi-load at a time, so it's different. But if you're 1/10 of that tank, you just lost 1/3 of your month's milk check. Okay, so let's take a look at metric capacity. When they did the metric system, as we mentioned, it was planned out. They knew about all the issues with the standard measuring system, and they tried to correct them, tried to take them out, tried to avoid them. One of them was this idea that there was just no good conversion between units of capacity and units of volume. So in the metric system, they defined their unit of capacity to be a liter. Now, if you remember, we had our prefixes, deciliter, centiliter, milliliter, decaliter, hectoliter, and kiloliter. Now, realistically, the liter caught on, the main unit caught on, and like with our length units, the milli caught on. Kilo, not so much. A kiloliter is like 380 gallons. It's pretty big. So it was really bigger than what we really needed for most things. The deciliter gets used a little bit in medical testing. If you ever had your cholesterol checked, and let's say they tell you your triglycerides are 180. What that is 180 milligrams of cholesterol per deciliter of blood. Or if you've had your blood sugar checked and you come back at like a 102, same thing, that's 102 milligrams of blood glucose per deciliter of blood. That's the only place I've ever seen deciliter really consistently used, is in blood and urine testing and medical testing. But anyway, that connection between capacity and volume. 1 milliliter is defined to be 1 cubic centimeter. So 1 centimeter by 1 centimeter by 1 centimeter is a milliliter. So converting from volume to capacity in the metric system is quite simple because the capacity is defined off of that. So if we have a tank let's say this is 130 centimeters by 40 centimeters by 20 centimeters. To find the volume of this, we're just going to do a shortcut. We're just going to do length times width times height to get it over with. 104,000 even centimeters cubed. Well, that would be how many milliliters? A milliliter is defined to be a centimeter cubed. So a centimeter cubed is a milliliter. So 104,000 cubic centimeters is 104,000 liters. So how many liters would that be? From milliliters to liters is 3 spots to the left. 104. So just move the decimal point 3 spots over. So 104 liters in that tank. Now we have to do the awkward conversion between metric and standard. 1 gallon is about 3.785 liters. So if I want to convert that 104 liters into gallons, I'll put liters on bottom, gallons on top. 1 gallon is 3.785 liters. So I've got 104 gallons divided by 3.785 is 27.4 I'd say 4.8 we'd round it to. Gallons. Not terrible, but I mean, it's an ugly conversion. But you can see how much easier the metric system is to work with for those volume to capacity conversions. Okay, if you guys give me about 6 or 7 minutes worth of homework, we'll let you out of here. We're going to be looking in the big book. There's actually like 4 pages here. Page 302, exercise 8 actually 302 is not correct for your book. I believe it's page 253, exercise 8-9. Page 254, exercise 8-10. Page 274, exercise 9-11. And page 274, 275, exercise 9-12. So obviously the 8-9 and 8-10 are the standard units, 9-11, 9-12 are the metric units.